been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
All right, this video is for section 2.6, geometric proofs, specifically dealing with segments and angles. So when we're doing a proof, these are the possible reasons that we will have in our right side column. We can use definitions, we can use properties, we can use postulates, and we can use theorems, but we can only use theorems after we have proved that theorem. So throughout this course, we will prove some of these theorems. And again, you can only use a theorem if you've already proved it before. So let's go ahead and do an example. So it says given segment AB and midpoint M. So I don't have a picture here. Well, I need to draw a picture. So segment AB looks something like this. And midpoint M, so that means M is right here, which is the midpoint. Now, what do we know from the midpoint? We know by definition of the midpoint that this segment is congruent to that segment. Now, we know that from the definition, but we're going to have to actually include that in our proof. We're trying to prove that AB is equal to 2 times AM. Okay, so let's go ahead and set that up. Remember, the first statement will always be what was given, and our reason for that is that it was given. So the next thing is we talked about that segment AM is congruent to segment BM. And that is by definition of the midpoint. So I'm going to say midpoint definition. If the segments are congruent, then the distances are equal. And that is the definition of congruent segments. Now, why is it important that I include that? It's important because I'm trying to prove something about distance, not about the segment. So I need to have distance in my proof. Now, we also know that segment AB, the distance of AB, is equal to the distance of AM plus the distance of BM. That is the segment addition postulate. Now, if AM equals BM, then I can substitute one for the other. And I'm trying to get that AB equals 2 times AM, which means I want to substitute this AM in for this BM here so that I can have 2 AMs. So AB equals AM plus AM, that is substitution, and AB equals 2AM, which we just simplified. So given the statement, we proved that AB, the distance of AB, is equal to 2 times the distance of AM. We used definition, postulate, and properties. Substitution is a property. So as I mentioned earlier, we're going to use definitions, properties, and postulates. We didn't use a theorem here because we really haven't proved any theorems. So that's what we used. Here we have given lines J and N intersect at D, which is a point. And I actually have this picture given. The reason being because if they're asking me to prove that measure of angle 4 is equal to measure of angle 6, I need to know what angles they're talking about. So that's why the diagram is given. So let's think through this. 4 and 6 are vertical angles. Well, we're actually going to write the proof for vertical angle congruence. So we are going to do the vertical angle congruence theorem. That's what we are actually proving. So given lines J and N intersect at point D. So what do I know here based on definitions and properties? Well, I know that angles 4 and 5 are a linear pair. I know that a linear pair is equal to 180 degrees. I also know that angle 4 plus angle 5 equals 180. So that's probably what I'm going to use, because if 4 plus 5 equal 180 and 5 plus 6 also equals 180 and 5 equals itself, then I can probably prove that 4 and 6 are the same. So the next thing that I'm going to say is that the measure of angle 4 plus the measure of angle 5 equals 180 degrees, and that is by definition of a linear pair. And then I'm going to say the same about 5 and 6, again, because I need the 4 and 6 to be included. Now, what I have here is I can actually use substitution, because if 4 plus 5 equals 180, then that means wherever I see a 180, I can substitute measure of angle 4 plus measure of angle 5. So again, wherever I see a 180, I could, instead of 180, I could write measure of angle 4 plus measure of angle 5. So I'm going to say that the measure of angle 5 plus the measure of angle 6 equals, instead of 180, I'm going to say the measure of angle 4 plus the measure of angle 5. That is substitution. So if 5 plus 6 equals 4 plus 5, then all we have to do is subtract angle 5 from both sides, and we would get 6 equals 4. So I'm going to show the reflexive property first, and then I'll show my subtraction. And if I wanted to be really picky, my last step would be that the measure of angle 4 equals the measure of angle 6, which is the symmetric property. But I am not going to require that. I just want to point that out to you because it's technically asking us to prove that measure of angle 4 equals measure of angle 6, and I had it flipped around. So, but we know by the symmetric property that that means the same thing. So we just proved again the vertical angle congruence theorem. So now if we're trying to prove something, we can use that theorem in our proof without having to redo this all over again. So those are two examples of how you prove geometric proofs using definitions, properties, and postulates.
I've been waiting way too long. Yeah. I've been out here trying to get it. Yeah. I've been waiting way too long.